Okay, Chapter 4, Question 118. The combustion of liquid ethanol produces carbon dioxide in water. After 4.62 milliliters, 4.62 milliliters of ethanol, that is ethanol is C2H5OH, 5OH. Okay, let's see what else we got. Density of ethanol. Density of ethanol is 0.789 grams per milliliter. 9 grams per milliliter. What else we got here? Allowed to burn in the presence of 15.55 grams of oxygen gas. So that is O2 gas equals 15.55 grams. Where else are we here? Yields 3.72 milliliters of water. Okay, so volume of H2O equals 3.72 milliliters. Yeah, with a density of 1 gram per milliliter. Alright, sure. Okay, so density of H2O is 1 gram per milliliter. Alright, determine limiting reactant, theoretical yield of H2O, and percent yield for the reaction. Alright, here we go. Okay, first things first, every time you've got any kind of a question that looks remotely like this, you start with a balanced reaction. So let's wall off our values there, and let's do exactly that. Alright, ethanol to H5OH. Okay, oxygen. O2 gas. You know what? You guys can write the states, but I'm writing badly enough on this that I'm not going to. Carbon dioxide. It's also a gas. Plus H2O. There we go. That is everything. Okay, so off to the balancing then. So two carbons in the ethanol. So we're going to have 2 CO2s. How many of these? We have 6 of those. So 3. There's hydrogen balanced. And we have 1, 2. What do we have? 4 and 7, right? 3 here plus that makes 7. 1 there, so then we need 6 here. So this is going to be a 3. There we go. There's our balanced combustion reaction. Okay, so limited reagent. Let's start with that. So let's find. We're just going to find the moles of each of our species up here, and we'll see which we have less of. Okay, so moles of. Let's do ethanol first, since we have all the figures for that. So moles of OH. That's going to be we need mass over formula weight. We're going to get mass by multiplying the density by the volume that we got. So this is going to be the volume times the density divided by the formula weight of ethanol. Okay, let's back that equal sign up so I got some room. 4.62 milliliters times 0.7899 grams per milliliter. Okay, so that's going to take care of the milliliters. And we divide that by a formula weight of 46.068. 6.068 grams per mole. All right, and that takes up the grams. We're going to be left with moles. That's exactly what we want. 8.08 times 10 to the negative 2. 08 times 10 to the negative 2 moles. Okay, let's put that over here. All right, moles of ethanol equals 0.0808. Okay. 1 down. next let's find the moles of oxygen. Moles of oxygen are easier. We got the grams directly here. So moles of oxygen equals 15.55 grams divided by the formula weight of O2. Don't forget the 2. Means it's going to be 16 times 2 makes 32 grams per mole. And that gives us a total of 0.486. 0.486. Okay, moles of oxygen. 0.486. So we have a 3 to 1 stoichiometric ratio between the moles of oxygen and the moles of ethanol. So we're going to have to account for that here. So that means we're asking whether this is greater or lesser or equal to the moles of oxygen divided by 3 because of that stoichiometric ratio. 3 of, oh, good grief. 3 oxygens. Okay. And turns out this is still bigger. This gives us 0.162. So this is definitely much bigger than this one here. So we're going to be limited by ethanol. All right, so ethanol is our limiting reagent. All right, equals ethanol. Okay, next, let's find our theoretical yield. So now that we know how many moles we're going to react, we can use the, okay, this was a 2. Sorry, I'm just going to kind of put this back together there. All right, so 3 waters to 1 ethanol. It means that we can get a theoretical yield by multiplying the moles of H2O. Well, find the moles of H2O. Oh, right, because we need it in mass. Then we'll multiply it by the formula weight. All right, let's find the moles of H2O first. So moles of H2O equals moles of ethanol times 3. Moles of ethanol times 3 moles of H2O divided by 1 mole of ethanol. Alright, so those will cancel each other out, so we're just multiplying this by 3 straight away. That gives us a total of 0.242 moles of H2O. Okay, and then we need this in mass, so we're just going to multiply it. We're going to get that by multiplying by the formula weight. So 242 moles times formula weight of water, that is 18.016 grams per mole, which gives us a total of 4.37 grams. There we go. So that's the theoretical yield. We'll put that up here. Theoretical yield equals 4.37 grams of H2O. Okay. And then we need the actual yield. And the actual yield is just we need the percent yield. Yeah, sorry, excuse me. So percent yield is the actual yield over top of the theoretical yield multiplied by 100. So percent yield equals actual yield over the theoretical yield times 100. Okay, so how much did we actually get? We're not actually, this is 1 gram, so I'm just going to write this in grams directly. So we got 3.72 grams, right? I'm just multiplying it by this to get grams out of that. Theoretical was 4.37. All right, multiply this thing by 100. That gives us a percent yield of 85.1%. And that is everything we needed.